Good morning, good morning, good morning.
And welcome to this MVP Led Tech Days Online 2017. We have a packed full 3 days full of everything from bots to data to quantum, everything you could possibly want. So stay in tune for 3 days with us and learn lots of new stuff. If you're not registered but you fancy getting registered now, you can still do that at aka.ms UK Tech Days 2017. You can also actually just go straight to the Channel 9 homepage, channel9.msdn.com.
We have taken over the homepage, haven't we?
We have taken over the homepage. And any questions on any of the talks, you're going to get talks from lots of people with loads of great knowledge. Please go to aka.ms, ask questions FB to our developer Facebook page. And that's a place where we'll all sit afterwards and answer any questions as well.
And of course, if you're using Twitter,
Indeed.
hashtag UK Tech Days is the place to place comments and feedback and other discussions. So please retweet some stuff.
Yeah. Okay, so like we said, full packed agenda. You are currently here. It is 10 a.m. and we're going to be talking data, how and where to store your data on Azure. We've got a full day of lots of things from bots to data today, but then tomorrow it's all about open source, and then moving on to Wednesday where it'll all be about the future of technology, so things like quantum and blockchain. But also, breaking news, we've actually got Jean Kim at 3 o'clock on Wednesday actually talking to us about DevOps as well. So nice little late addition there.
So on that note, let's actually drill into who we are and a little bit about us.
You go first.
I'm David Gristwood. So I and Amy Nicholson here are going to spend the time giving us a lap around data, why, how, when on the Azure platform.
Great stuff. So let's start here, shall we? We've gone icon mad in some senses.
We have, and this is, right, we're going to spend a little bit of time talking about this to set the scene for the rest of the talk. So the bit in the middle, that's where we're going to be spending the bulk of our time. There's a lot of services inside of there. We've also bizarrely listed some things we're not going to be talking about, and there's a good reason. We're not just randomly doing this, why we're not talking. So on the far left, up in Azure, VMs. If you've got a favorite database engine, a storage technology that works on hardware or on a VM today, then you can just put in a VM up in Azure, set your VNets, glue everything together, and use it as is with no changes. So from a developer viewpoint, that's really not that interesting. So we're not going to dwell on that because it's business as usual. And always, your VM is your get out of jail card. If there's something that we don't offer as a service or don't quite meet your requirements, you can always do that. Now, we're mainly focusing on persistent stores with one sort of minor exception. The two bits to the right-hand side, caching and search, we've got them there for a good reason as well. So in order to speed up and optimize elements of your application, you'll like to turn to caching. And if we look at, say, Redis Cache, which is, I think we'd argue is probably the most popular
one,
cache service out there, wide usage. It's an open source project. You can certainly stand up your own VM and put the Redis Cache in there. But we run it as a service.
Takes away all that worry, I guess, about running a VM.
And this is one of the themes we're going to be sort of exploring. So if you need to do sort of look-aside caching to optimize certain types of lookups, or you want to hold sort of things like session state, for example, this would be the way you do it. Now, also search is there, which overlays a number of other data sources. Tell us a little bit about that, because you've spent a fair time there.
I was going to say, search as a service, I guess. So you don't have to be an expert in search to actually be able to put it in front of your applications. So you're an application developer, you can actually now bring your data into Azure, index over that data, and then be able to call via a REST API to get that kind of search capability into your applications. It's a really neat way to just be able to say, don't worry about the infrastructure, all of the complexity that search might bring to an application. Don't worry about that. Bring the data, index it, and actually be able to query on it.
And this bringing together different data stores is what we call polyglot persistence. Is a common theme here we're exploring, because in the past, when you were dealing with on-prem systems, you'd spend a lot of time with a particular technology, say SQL Server. You'd learn all the intricacies. And the thing about SQL Server is it wasn't just the database engine. There's the reporting service, there's the integration service, there's the SQL agent, there's an analysis service.
There's tooling that goes with it as well.
All this sort of stuff. And because the boxes required optimization to set up, people would use the one box and really get the most out of it. So the SQL team added file stream capabilities, for example, in order to take your files, because the file system hadn't really evolved. When suddenly in the cloud, everything's a service, and you don't, as you say, have to manage VMs, then you can start to pick and choose different bits of your application. So we see people making decisions like, well, I've got my site, and I'm going to put session state in the Redis cache, so it's sitting outside an individual machine. So if I scale up and scale down, websites being, non-persistent data stores, you don't want to lose them, so push that state there. And then, as you say, with search, you might say, if users want to search on my site, I will use the Azure search, and I become a search expert without really getting much into it. We take things like faceted search of categories, which are quite complex areas to work with. So if you've got a site selling goods and someone looks at an Olympus camera, you're able to spot the fact that Olympus is a brand of camera and that there are other cameras available like Nikon and Canon and Sony and the like, and guide people through that search without having to become really in-depth knowledge about that. And you might say, for my NoSQL store for the product description stuff, because no schema makes sense for product description, but for my ordering and line of business system, I want a more traditional transactional repository to put the data. So people build up this stuff like this, and because it's easy, just sort of set it up as services and just glue them together.
Yeah, the right repository for the right type of data, I guess, in some senses, is going to be the flow through this presentation.
That's it. And at the bottom, we're just going to mention that there are a number of ways of getting data in there. What are the two different approaches that we've highlighted?
We're going to talk about those data stores above it, but actually, how do you even get it into the cloud first as well? And we've split those 3 services at the bottom for data ingestion. On the left there, we've got Data Factory, which is more of a maybe like a bulk load, more kind of transactional piece where you might go, once a day, I'm going to push this set of data into the cloud, and I'm going to process over it and pop it into a data store. And
this is often human-derived data that represents things in the real world, like my sales and my orders and stuff like that.
Yeah, so things that we're accumulating across the day, maybe sales are happening, maybe customers are interacting with your website, something like that. These kinds of things can go in via Data Factory.
But there is a different category there on the right for the very different nature of machine data, isn't it?
Machine data, and also data coming at us maybe at a much faster pace as well. So things like event hubs and IoT hubs are a really interesting way of thinking about real-time data. How do you get that streaming into the cloud? 2 different services. Lots of people will say, when to use what again?
So what's the guidance here?
I'd probably say IoT Hub is when you have little devices, or maybe big devices as well, any kind of device that actually you need to understand and actually communicate bidirectionally with that device. So whether it's things like a lot of people connect obviously small devices, temperature sensors, stuff like that. If you connect one of them, you actually need to be able to maybe talk back or change the temperature or something once you've done some kind of processing on that data.
And I'm guessing being confident that is a valid device to be connected. There's a whole security thing about rescinding devices and making sure that there is some sort of security that random devices can't just drive by and connect.
Yeah, I was going to say there's lots of handshakes with the cloud there where you can say, this is a trusted device, I know it's a trusted device. And actually, if you suddenly think that it's potentially been compromised, you completely cut it off. You can cut off that communication, and you know that your data is consistent then. Whereas the event hubs piece is maybe when you don't have a device, so maybe something more like social media, transactional kind of logs, maybe from a website, something where you're passing data very, very quickly, but you don't need to marry it to a certain item.
Now, one of the things that are important for both these services, they actually lay data at rest whilst we're loading, because you mentioned Twitter, you don't really want to sort of open your mouth to the fire hose of this Twitter and try to swallow the whole thing. It wouldn't be possible. But putting, we're architects, we know that there's no problem that can't be solved by a level of indirection. If we use something like Event Hub between us, it can absorb the data, and in the back we can sort of downstream pull the data out at a much more comfortable pace that we can cope with. So it helps us buffer and level the loads coming in.
Absolutely. So just that bit at the bottom, all around data ingestion. How do we even get data into the cloud and actually consume those services above there?
Right. So let's focus for the rest of the talk on the services bit. And there is a sort of vague pattern to this. Left to right, we have a sort of building blocks to bigger high-level services, and in the middle we have our sort of line of business with and without schema. So let's drill into that.
So first up, we've got Azure Storage.
This is the granddaddy of the storage. When Azure was first launched, this was one of the core services that existed, and it was about making really high-scale, high availability of data, like we're talking hundreds of terabytes up in the cloud. And this is what happens. You create systems, you're amassing data, it's going to grow over time. So you need something that's cheap and flexible and scalable, resilient and robust. And we went back to basics and rebuilt a REST-based API to access this. So we're taking all the modern things of the cloud of shared access signature, making sure that we can sort of use URI-based mechanisms for addressing it. It's been successful, obviously, for lots of people, including ourselves. Skype, Office 365, Xbox, OneDrive, and a load of other services out there have taken these building blocks, especially the blobs, and built an entire set of services on top of them. The three main ones from a dev perspective are blobs, tables, and queues. Blobs probably the most interesting because they represent the file system on the cloud, don't they?
I was going to say, you can put unstructured data in there as well, kind of put all those different types of files in there.
Yeah, whereas tables are a lightweight no-schema type thing, like a NoSQL, with just one single field for keying on for doing your indexing and stuff like that, and some limits on the size of the data and the number of actual key value pairs there. So we're going to come back and look at this whole NoSQL area later on with document DB.
Again, when to use what. We do have a couple of different offerings. It'll be figuring out what's the right one for the right job. That's
exactly it. And queues, well, they work like you'd sort of expect in any distributed system. We want to sort of load level and decouple parts of the system. We know from past experience that systems that are tightly coupled lack the flexibility to cope with loads and adding more resources and services. So we use queues to put a level of indirection between, say, someone posting some data and processing it at the back end. There is service bus, which tends to be used more between different systems or different development teams, whereas queues tend to be used more with your own development teams because there's a shared key model under the cover.
Yeah.
The one thing that we will mention, files do exist, SMB access. Originally, they were not part of the load coming up to Azure, but we got a lot of feedback that not everyone was ready to do the leap straight up and re-architect everything for Azure. And there's lots of people who just love file semantics. There's lots of, and it's been around for years. We tried a couple of times to evolve the file system. Folk remember WinFS. But people are resilient because so much code uses it. So the files, the SMB capability is a core part of that. A couple of mantras that are worth saying: never lose data. So we keep a triple replicated store of your data within one data center.
Okay.
And if you tick the box, basically saying, can we geo-replicate it, we'll make another 3 copies in another data center.
So that'll be 6 copies across.
At least 100 miles away between them. So this is sort of, giving you, the ability to be sure it won't be lost. And if you do the read access capabilities, you could actually take load off the core system by reading from the copy. As people put more and more data up there, they started to look at how much does it actually cost. So we have the hot, which is the normal data we've been working with, but we recently introduced cool as a sort of rarely used, more archival based stuff, which is at a lower cost.
Yeah, which when we're getting so much more data, there's data coming from almost everything now, that actually having some of that more cool archive storage is a great asset.
It is. People say, I've got to store 10 years worth of emails or stuff, or I've got an archive that needs to be around for 7 years for legal reasons. So, well, great, throw it in cool storage. You know it's going to be safe there, and it's at a lower storage cost. It costs from 1 cent per gig per month to put it there. Finally, mention a couple of things that, based on feedback, we've enhanced encryption at rest. So when you read and write, we automatically handle the keys under the background because, again, we know some folk need to build systems where the data must be encrypted at rest.
Absolutely,
So it's a really easy way to do that. There's well-defined performance targets. So if you use your favorite search engine, Bing, other search engines are available, and look at the well-defined performance target, you'll see all these details like, 500 terabytes for storage account, 20,000 IOPS or accesses per second, and so on under there.
Brilliant.
Right, so that's the building blocks.
The bread and butter type storage.
Right, so let's start moving up the stack just a little.
It's a SQL database.
Database as a service. So people are used to sort of installing SQL, as we were saying earlier, on VM, but if you imagine a slightly different way of approaching the situation, think about our data centers. We've got row after row of all these servers running this specially optimized version of SQL as a service, and they're sitting there, so you don't provision them, they're already there. And you just connect with the service and say, give me a database. And we go, yep, sure. And boom, it comes straight back because we've got everything already set up there. It's based on the SQL Server engine, so highly compatible. So the migration for what we call internally the V12 up in Azure, it's a very easy move to make. And the idea, as we've discussed in the past, is to free up time from maintaining and monitoring and networking and all this other stuff.
You can focus more on other parts of your application then. You want to have a transactional database, if that's the right fit for the right data, call in, query it, be able to just look after it, know that it can grow and scale as well. So it's a neat offering.
Now people are into this mentality of it just works. So that's what we want to do. We have different tiers that help with the pricing size of things. So we have sort of a basic which goes up to 2 gig, a standard goes up to 250 gig, a premium that actually goes 1 terabyte and potentially beyond there. And so you're sort of saying not only what's the size of your data, but what the capabilities. And the best analogy would sort of be a car one. It's like, manufacturers have different ranges, like BMW have a 3 Series, a 5 and so on. And the idea is each one has a higher level of capability, more luxury, more good. But within them, there are different engine sizes. So we have this whole tiering, and you can set up different ratings within those and change them in real time.
As and when you need it.
That's it. That's a bit that people sometimes forget when they look and go, yeah, but if I got this and that, you go, no, how about if your app's not being used at the weekend? Dialing it right the way down and dialing it up in peak times when you need to do a bulk in load. Why not dial it up during that? So there's a lot of benefits to be got from this.
Just a quick double check, the SQL database, just the core engine, isn't it, up in the cloud?
It is just the core engine.
Yeah, always a question I get asked.
Yeah, because we'll talk about dashboarding towards the end, and we'll talk about some of the other mechanisms later on, yes.
Brilliant.
Because you don't own the machine, because we manage it, we need a better way of representing how powerful a database is, and this is what this diagram to the right on the slide is. DTUs, database transaction units, they're a bit like horsepower. If you're going to keep with the car analogy there, the idea is that something that's got a higher DTU works faster, and there's a sort of linear representation within the different service tiers to that, so that you can dial it up, and it gives you an abstract way of reading. It's a sort of blended mechanisms. There are MSDN articles on this, but in the same way with the horse, in a car, I don't know what a horsepower looks like.
Or the difference between maybe 1 or 2 extra horsepower, but if it's a big jump, you probably go, yeah, that's a really fast car.
That's exactly it. So again, if you want to look into that, there's documents there. So again, taking some of the things that people come to expect from an on-premise thing, so it's secure in the transparent data. Encryption is there. We isolate them, so if you're building multi-tenancy systems. We monitor, so there's audit capability, there's masking of sensitive data, there's a lot of things you just expect are just there automatically for you to use. You don't need to think about it. Some nice areas where we really do benefit is point-in-time restore. So you don't back up, we just restore. Just tell us when you want it.
Right, okay. That's neat,
That is really neat, because no one likes the hassle. Everyone puts it low line on the list. So we just automatically doing it in the background without you having to do anything. And we actively geo-replicate, so it's the same model that we have elsewhere. For the blob storage, we have a second copy elsewhere.
Nice. Okay, so relational transactional data there. Moving into a slightly different territory, I think, with this one.
No, so Alan Mitchell's doing a session later on today talking about NoSQL document DB. So he laughs in the face of schema, he does. And so the idea is here, because we've got this polyglot world now, the idea is if you've got data that doesn't require the rigor of ACID transactions around it, if it doesn't need the focus on schema, then just throw it out, get rid of it.
Yeah, if you need more flexibility, isn't it? The kind of NoSQL world is more in your favour when you're growing user data or something like that, and changing your application over time.
That's it, and we've seen people do really unnatural things with relational data to represent ragged, non-schematized data. They've done third normal formats across multiple data to the point where no one can read what on earth the data is, whereas JSON would have been a perfect way of representing that. Brilliant. So this is it. So it is a JSON-based NoSQL engine. So if you're into NoSQL, this is the place you should be looking.
Thanks.
Nice capability as we have a SQL-like language for representing the queries. So it's kind of taking things that you know and just sort of adopting them. If you're a .NET programmer, you support the link programming model. So you can do those set-based operations inside your code. So that's very, very neat there. And if you've already done work with things like MongoDB, we have a compatible API.
Right.
And if you want to extend it with stored procedures, use defined functions, triggers, and the like, JavaScript. So if T-SQL is not the language you first come to know and love, and perhaps lingua franca these days is JavaScript.
I was about to say, it's coming into lots and lots of our different services as well, isn't it? Lots of different editions of JavaScript.
But just because, people have cut their teeth on the web building JavaScript on the client side, so taking those same ideas and the same language just makes a natural, way to migrate up there. The thing that the team, obviously the engineering guys, are really keen to specify is guaranteed low latency no matter how big you get. So sub 10 millisecond on read, sub 15 millisecond on writes. They really love this.
Fast item that the marketing team goes with.
They do love
I agree.
that. And they index on all the fields, so they really want to make it easy just to throw the data in and get it back out again. They do clever things under the cover around partitioning, which again, you don't have to do anything other than just say, we're going to have a partition to help us level load. Once you get above 10 gig into the next size, which is up to 250 gig, you need really to do that to sort of make the thing perform well under the cover.
Okay. And so when's the time, where's the split almost between, we talked about table storage being in NoSQL, the bread and butter kind of storage services, and then we've got DocumentDB, this blazing fast hyperscale. Where do you see the crossover? What are some of the things where you go, actually, DocumentDB we need for this?
I think if you're doing low-level indexing and doing some logs and things like that you just want to throw somewhere that you want to search, and your retrieval pattern is one indexed field.
Just kind of going,
just go pull it, then absolutely fantastic. If you need something strong, you need to say index all the fields. If you really want high performance responses, then this is the place to do that. And finally, note at the bottom there about consistency models. One of the things that people really love about NoSQL is to be able to sort of free yourself from the strong consistency that's more in line with ACID transactional stuff, and actually have an eventually consistent model where you want to trade off consistency for high availability. Like, I'd much prefer it was there, so that you just throw your request, even if it takes some while to permeate that data through the system, rather than if I can't do a transaction and commit it across all the different stores, I want you to roll it back and throw it back to me. So we have a choice of 4, strong and eventual being 2 ends of the scale.
Okay, awesome. Okay, so we've gone SQL, relational type data, we've gone NoSQL. What's up next?
So we're now starting to move away from the line of business systems into the warehousing. So this is something I know that you're going to be touching on more on the big data side. But the idea is, back to our analogy of a website that's doing all these bits and pieces, what they may also do is take all the click-through and all the interactions people have had through the website, take a copy of it, put it in a data warehouse for later analysis. So this is not your line of business. This is taking the data, doing ETL, extract, transform, and load, putting it somewhere else for later analysis.
Okay.
And typically, of course, that means you're going to be amassing large amounts of data. Imagine looking at every time someone adds something to a basket, or every time someone clicks a page, and you're going to try to want to pick up the patterns. Where do people go? Where do they not go? Where do people drop out from the basket and not commit to it?
Yeah.
Can you get some insights into it? So SQL Data Warehouse is our solution for this. The nice thing is, from a programming viewpoint, it just looks and feels like SQL because the core engine is that. But under the cover, it takes the queries that come in as T-SQL via TDS and just pushes them out to parallel databases. So we have a shared nothing.
So it deals with all of that resource management type thing. You don't have to worry about it.
That's exactly it. Nice. So it makes it really, really easy. We can use Polybase to do non-relational and ragged stuff, which I know you're coming to. And also, this is the first time we're starting to see a trend of separating work from storage, which I think is a very smart way, because the idea is, with the relational data, it's on there 24/7, it's doing all the business work, it just needs to be there and responding well and all the different...
Always ticking over type thing.
That DTU is helping you match the lowest cost against your workloads and change that. Whereas warehouses tend to be burst scenarios where you've amassed a lot of data and you say, go search for all the people who got 5 items into their basket who were in North America and then didn't go to the checkout. I say, that's a big bit of work. You're going to have to crawl through a lot of data to get there. And the idea is get a bursting, so you only pay for the CPU work while that's taking place, get the results, land them out, and then turn down the dial on CPU. So it's a very effective way of paying.
So it's got like a pause and resume type capability, and I guess that means that you're saving a lot of costs in some senses. Compute is the cost.
Yes, that episodic workloads play really well to that. And if we look at the next slide, the analysis services thing, it's taking that idea of a warehouse to the next level, and this is the one where we actually do bring it in memory. So analysis services were in part of SQL there, and it goes back a long way. It's a proven technology. Yeah, people are used to building queues, rollup, molap, MDX queries, pre-aggregating lots of stuff. And the reason they're doing all of this is users.
Right.
end users, are sitting in front of a dashboard and going draggy, droppy, pointy, clicky. I just expect this to move really fast. When I click on this, I just want to see a graph, and I want to see it across the world. And as I zoom in and zoom out, I just want it really responsive. And the poor developers who are looking at the back and go, yeah, actually, that's really tough. People have somewhat unrealistic expectations about what's there. So the idea with analysis services is you take a subset of the data that you want to expose as a dashboard, load it up, bring a model into play. So this is typically a fact and dimension setup. So the idea is here with snowflake type schema. So you perhaps, if we go to our shop analogy, imagine you were taking one row in a database for every item that was sold in every store in every country.
Right.
It's a big long table, not many columns to it, but lots and lots of entries, and a few dimensions to help you understand that certain cities are in certain states and certain countries, and that certain dates sit in financial years or quarters and the like, so that someone can sit in front of the dashboard and say, show me all the sales of this model of trainer in France in July by store. Okay, that's a lot of stuff. But by bringing it to memory, we're using this Vertipack X-Velocity technology under the cover so we can really reduce that down. It's in memory, it's blinding fast. And by putting this analysis service in Azure, which is still in preview at the time of recording, between the data store and the dashboard, we get really blinding fast performance.
Great stuff. And I guess that user piece as well is that we don't always name columns in databases very nicely. They've often got underscores in them, camel case type things going on.
So that's a good point. Is part of that ETL is to pick better names for columns and not necessarily do third normal format. Actually, it's okay to repeat data if it makes it easier for users to build queries that make sense, because this whole thing is being loaded into memory and you're trying to make it user-friendly. This is not your line of business system, so we can afford to replicate data for ease of use.
Okay, nice. So data warehouse pairs very nicely with analysis services and then pushing it out to that dashboarding piece. So you've got a bit of a pipeline building up already there.
There is a definite pattern there of your data source and this sitting in between. But I think you're going to next talk about some of the alternative data sources, some of the newer ones in the world of big data.
Yeah, so we've talked a bit about relational, NoSQL, so we've talked a bit about different ways of kind of charging through that data and big stores and whatnot. And actually, we wanted to kind of move into this idea of big data. Now, big data is an unusual word. We're never quite sure exactly what it means, but I think the 3 V's are a really cool one.
And remind everyone what the 3 V's are.
Variety, velocity, and
the other one.
And the other one.
Volume?
Volume, sorry. So volume, obviously, the sheer size of the data in some senses. You've got variety, the different types of data that you might be getting, whether that's structured, unstructured, semi-structured, a bit of both. And then you've got velocity as well, so the scale at which it's coming at you. So whether we talked a bit about that data factory V sort of event hub IoT kind of piece, is it the hot pipeline? Is it the fast data that's coming towards you? Or is it more that transactional piece and actually we're going to do some analytics over maybe stored data, for example?
Is it fair to say then that it's these bigger V's that are coming in that are causing us to think about approaching the problems with different tools and technologies? Because things that once upon a time people would just load into Excel and sort by column, we're moving into a different world here,
I was going to say, I mean, you have things like Power Pivot, Power Query, stuff like that. Great technologies, a bit like the analysis services stuff, where you can get fast and it can, really shrink down and optimize that data for you. But then this is getting into just mass scales of data where you really need to. You're probably going at it from a more analytics point of view, where you're going, can we start to do predictions? Can we start to do forecasting? Can we understand much more out of this huge amount of data, but also that kind of data where you go, oh, it's not just columns of data, or it's not just, it might be images, it might be sound waves, it could be anything, all these different types.
I get a sense that there's a lot of work that needs to take place to get your data into a format where you can start doing some of this. And this whole cleanliness and quality is something that we're just touching on.
I was going to say, there's a whole extra piece around this. We're only touching the surface, but just to introduce it to people and know what's on offer. So first up, we've got HD Insight. I'm sure many people recognise the elephant here. It's our Hadoop elephant. And HD Insight is actually one of our fully managed cloud Hadoop offerings. So being able to use that open source analytic clusters inside Azure. So what does that actually mean? So in the past, you would have to be concerned about how much infrastructure you would need for this big data analytics. And actually, In this case, what you can do is you can actually just create a cluster. So you design maybe what it looks like, how big you need it to be. We have also these predefined services, so lots of the popular ones, Spark, Hive, MapReduce, things like HBase, and then moving more to real time with sort of Storm and Kafka as well.
And a lot of these happens just over the last 10 years, aren't they?
Absolutely, yeah. I think I was looking it up. 2006, I think it comes up. Yahoo were heavily involved. The papers came from Google originally, the original research papers.
This is the MapReduce stuff.
The MapReduce stuff. It was interesting actually to have a good read through it and see where it had all come from. But one of the nice things about this is actually create this cluster, run it. As it's running, run these jobs over it, run a lot of your analytical jobs. But once you have those answers, once you've run over that data, tear it all back down again. You don't need to have the mass sort of infrastructure up front and have it always sitting there. A bit like the data warehouse in some senses, that kind of pattern of spin it up, do your data analysis, and just tear it all back down again.
And we've seen analysis that's showing that prior to all of this, something like 98% of the time these clusters were doing nothing, incurring a lot of cost, a lot of machinery. This is a much better dispersed model, isn't it?
Yeah, well, you only ever do it once. Spin one of these up and leave it going. You only do it once. And then, make sure you delete that cluster because you don't need it there.
Azure automation and other technologies are available to help you.
For another talk. But and a quick one on the storage options. So
because we've talked a lot about storage here and the different types. So what's the story here?
As much as this is on the compute side of churning over that, actually the storage options can be what people expect from Hadoop. So HDFS, Hadoop Distributed File System.
Yep, so that's the native store.
That's native store, and that can actually sit inside the cluster. However, that won't then be persistent because when you delete that cluster, that's going to be gone. So there's also other options that we've offered. So WASB, which is our blob storage account, you can actually call into that within your scripts and your runs of different jobs. And we've also added, obviously, one recently around Azure Data Lake Store. And
I'm guessing that was because when we first started doing this, we didn't have Data Lake, so the blob storage was the natural place to have that triple replicated cheap storage, but looking like HDFS sitting outside the cluster.
Also being able to hold that unstructured data as well as maybe semi-structured and structured data. And then finally, just on the skill set piece, this is obviously been around since 2006. Some people got into it right from the off, and this is a really valuable space to sit in. If you have a skill set in this, amazing, like really, really good stuff. But if you don't have a skill set in this, it can feel a little bit of a high barrier to entry in some senses.
It does feel like there's a lot to get around your head here, isn't
there? So many different services. So, if you have a skill set in this and you're already doing this kind of technology, HD Insight is brilliant for it. You spin these clusters up, you run your jobs on them, worry about the jobs, tear it back down, all good stuff kind of thing. However, if we move on a little bit into some other technologies as well that you can use, but this is a very, very powerful technology, and if you're in this space, definitely one worth using. So up next, moving less from the analytics, more back into the storage. Data Lake Store is one of our hyperscale big data analytics repositories, so it's absolutely designed for huge, huge amounts of data.
We use the word unlimited.
Unlimited.
And that is bizarre. It actually, because we're used to things like blob storage, for example, has a 500 terabyte limit, 20 storage accounts per subscription, all this sort of stuff. That has always seemed a lot to me. However, these guys go, no, don't even break sweat at this point.
I was about to say, you can store a single petabyte file, basically. So a file can be a petabyte in size, and you can just keep putting them in there, basically. And unlimited, it truly is a huge, huge hyperscale repository. So when you start to hit those limits, and it's and you're really hitting limits on the amounts of blob storage accounts, is it 20 per subscription or something like that? Maybe a data lake store is more for you. No predefined schema. So again, a bit like kind of the blob storage idea, really, but structured, semi-structured, unstructured data. Bring it in its native format. You don't have to do any kind of pre-transaction, pre-processing on it to neatly fit it in here. Pop it in the data lake. Obviously, you don't want your data lake turning into a data swamp in some senses.
Is that what happens?
I believe that's the lingo in this world. But
okay, yeah.
you know, make sure that things that are going in there, you do have a reason for them to be sitting in data lake store. So you do want to do analytics over them.
Okay,
otherwise, maybe your cold blob storage could be an interesting one. It's more archive kind of stuff.
Because you're actively working against this data.
Yeah, you're going to want to kind of query into this and actually have this huge repository for data analysis. And then finally at the bottom, just to kind of reiterate over that.
Because we've been talking about pricing as well, because up in the cloud and Azure, it is a sort of price-led architecture. You can make choices that will influence the actual running costs, can't you?
I was going to say, and this one's a really interesting one because this storage is done by terabytes, like hundreds of terabytes basically. So just go to the pricing page and you'll see the sheer scale that you can do, something like 5 million terabytes, give us a call is where it says then it has that contact us type link. So, you know, this is truly mass scale. There is a little bit of cost on transactions as well. To write to Data Lake Store is a bit more expensive than to read from. So just keeping in mind it's storage plus the transactions, storage plus compute type thing. And very quickly, we talked about HD Insight, the analytics piece.
Yep.
Data Lake Store can be the underlying data store for calling in from HD Insight. So it's got this web HDFS opportunity so that you can go in and do your MapReduce and Hive queries on top of a Data Lake Store as well.
So it seems like in the old days that with other servers on-prem, NTFS and the file system API became the default way of talking to on-prem. HDFS seems to have become the API for talking to really big data.
It's certainly very, very popular in this space, with this HDFS type
So
system.
We've worked to make sure that it looks and feels like it.
It's almost like you wouldn't even know the difference. You'd simply just call into it, get your data, and query over it. So we've done analytics, we've got the huge Data Lake Store. We actually have another offering in this space as well around something called Data Lake Analytics. Mike Reese is going to cover this later on today. He's going to be Skyping in, so from in the US. So hopefully we have a great session with him. So I'm only going to touch on this lightly, but Data Lake Analytics is analytics as a service. So with HD Insight, we said spin up those clusters, run the jobs, tear the clusters down. Take the cluster piece out, basically. It's focusing on writing and running jobs. It's all about submitting jobs to and from this service.
So this is thinking about when faced with a query, how do I go through all this data and do this complex query? How do I express that?
Yeah, so I mean, it's all very much related around this USQL language. Right. So USQL, we've had T-SQL, we've had this is another SQL-esque language. So USQL combines the benefits of SQL and C#, so that you can do the kind of declarative nature of select all from, extract all from, where this. But when you have these where clauses, you can actually inject some C# code in there. So it's very powerful.
So we can parallelize, in a sense, at the very high level by the T-SQL, but we can actually get very fine-grained control and actually manipulate the data into formats that work with. And this came out of internal research?
So this came from within Microsoft Research originally. A lot of research was done around this space, and it was actually used within our own search engine at Bing. Just to be able to have these, like you can imagine, weblogs, right? Just mass amounts of data sitting in this store and allowing actually the engineers at Bing to just be able to query down on that data and be able to get the insights they need out of it to improve the product.
And the Visual Studio integration, so you can actually start to get some insights, because I can imagine you could just put together a query, throw it, and then nothing much happens for a while, and you're wondering where the bottlenecks are and why it's taking so long.
I was about to say, this screenshot here on the slide is very, very neat. It kind of shows this deep integration in Visual Studio and being able to see the whole tree of actually how is your query split, what's going on where, how long is each section taking to run. And also, it doesn't show it on that one, but you can actually replay the event. So once you've run the job, you can replay, see how the query was actually run. But also get that kind of feedback on, well, where are the bottlenecks? Do we need more of these AUs, so these analytics units, this horsepower kind of idea to really push it through and finding that trade-off between analytic units and time and kind of saying, well, can we pay a bit more to kind of push this through a bit quicker? Obviously, it all matters on the parallelism of your queries as well.
Brilliant.
So very, very quick. So that was kind of flash tour around big data, around relational, NoSQL, lots and lots of different data as a service. But one last thing we wanted to mention is kind of that
it's our
front
favourite,
end piece.
it's
that
our
front
favourite
end piece.
yeah, our favourite technology for looking at all this data.
Yeah, so Power BI is our visualization tool. Allows you to, as you can see, connect to many, many different data sources, and a lot of the Azure sources that we've spoken about today can absolutely be connected using Power BI and using this nice dashboarding view. Use a free download called Power BI Desktop to actually create these reports, and then you can actually publish them up to the cloud. This is a dashboard as a service in the cloud type technology.
And people love dashboards, don't they?
Everyone loves a dashboard.
The days of green screen, paginated reports, no, people want to click and look and they want to see a lot of stuff and then click to get a drill down into an area. People love this once you've tried this.
It's very neat. It's quite modern. We're having lots of conversations with people about how they can move into this space and actually also start to embed this with inside applications as well.
So I think we've probably taken the time up with these good folks. So this has opened the Tech Days Online. Thank you very much indeed. You can follow us. In 15 minutes, the next session will be on bots, so we're looking forward to that. I think there's a video to roll. And of course, hello to Jason Isaacs.